I have experience in handling end-to-end projects on .NET, Java, Arkil, and Pega as well. And I'm well versed with the waterfall and agile methodologies. Apart from application development, I had experience in production support activities as well. So it's not only specific to the .NET, but you have any questions in generic about how the project works, how the production support works, feel free to ask me. I should be able to clarify any of your questions. So that's all, like a quick background about myself. Uh, so you want to quickly go around the table and just introduce yourself and give your brief background.
Yeah, no, sure. Thank you very much, Anna. My name is Sai Krishna Reddy. Right now, I'm working for a federal project as a database management specialist, and I have been in the market from last few months on .NET, and I'm continuing my marketing on .NET as well. Yeah, this is pretty much about me.
Okay, Sai, good to know. So basically, you are on the database side.
Yes, Anna. Right now, I'm working as
Okay,
a database management specialist.
okay, good to know, Sai. Thank you. Who wants to go next? See, the reason I'm asking is just I wanted to gauge you, like, how much you are into the IT so that I can plan my training effectively. If you are already having some sort of experience or like, learnings on the any of the programming languages, then it makes my life easy to go through the the .NET. So I can focus on the things which are very much required for you instead of focusing end to end, starting from basics to the end. So let me ask you my question different way. How many folks are familiar with the programming languages? We can chat
Hello.
here, you can say yes or no, if you're comfortable, not comfortable on speaking, you can just say yes or no in the chat. How many are you familiar with the programming languages?
Yes, Sana, we are a little bit familiar with C# and Java. So,
Okay,
yeah.
good. Anyone else? Okay, I see no from Harish. So I said yes. Okay, yes. Okay, Lali Chand, no. Okay. By the way, my name is Venu. Siva.
My
Okay.
bad.
That's okay. Okay, so I see a mix of few people knowing the programming languages and few of them are pretty new. Okay, so what I will do, I will just start with the basics. Okay, and if you think that like I'm covering very too much into the basics, then let me know. I can speed up, like instead of going with 1x, I can go with 1.5 or 2x speed. That way I can skip the topics which you are already familiar and focus on things which you are not aware. Okay, so let me share my screen. Okay, so let me know once you're able to see my screen. Can someone confirm?
Yes.
Okay, thank you. Okay, so we'll start with the basics. Okay, today my plan is to cover the basics about the programming languages and a quick introduction about object-oriented programming. And we can officially kick off the C# or the .NET the training from tomorrow onwards. Okay, so the basics, right? So what is computer language? Okay, so most of you know, computers can understand only the machinery language, which is 0 and 1, right? And it's always difficult as a human to communicate with computers. You cannot write anything with the machine code, right? Which is very difficult for us. It would be easy for the computer to understand, but from the human perspective, it's not easy to code everything in machine code. It's basically we can do, but it's a very time consuming and it's a very laborious task, right? So in order to communicate with the computer, we need some sort of medium, right? Okay, so that is basically, I would say, it is called a language. So you write some set of programs to communicate with the computer. Okay, so the programming language, there are like various types of programming languages. We have the machine language, we have assemblers, and we have high level programming languages. Initially when the computers invented, right, people started communicating with a computer using machine code. That means, they used to write everything in the binary language, zeros and ones. Okay, they put it on the CPU, and it used to run based on the code or input we have given. Okay, so maybe, if it is a simple task like adding two numbers or subtracting two numbers, we can easily convert the values into binary and put it into the CPU to run it. Okay, but nowadays, it's computers are everywhere, and we are writing very very big programs and complex data we are trying to process, right? So machine code is very fast. Okay, but the challenge is writing the code in machine code. Okay, and that's where slowly people realize that machine code may not work for us, because we are expanding and we are everywhere, and we need to process lots of data. Then we started introducing assembler language. The people who are familiar in the BTech, right, used to write 8086 programming. I'm not sure how many are from the BTech background, but in your academics you used to write 8086 chip designing, right? So we're used to write using the assemblers, right? So assemblers are, I would say it's an enhanced version of the machine code. Okay, it has some kind of mnemonics like add, subtract, okay, division, like that. Some it's like a little matured than machine code. Okay, but again, it's also very difficult. Okay, because as you see, computers are everywhere. We need to process lots of data, and we should have a mechanism to easily or effectively communicate with the computers. Okay, so then okay, so initially we start with the machine language, then we move to assembler. Okay, then we move to high level programming languages. Okay, so you must have learned some said already familiar with the C# Java. Okay, but there are various programming languages. Okay, so way back we used to write code on the Fortran, then basic, Pascal, C++, Java, and C#, right? So all these are called high level programming languages. Why it is called high level? Because it is very easy for the programmers to write the code using high level programming. Why means it's a simple English language you have to use. Of course, there is a standard syntax you have to follow depending upon the programming language, but it's very easy to write. Okay, so but the problem now here is you're writing the programs in English language, but computer can understand only zeros and ones, which is machine code, right? So how do you enable the computers to understand whatever you have written? Okay, that's where we have the concept of compilers. So the compiler, what it does is basically whatever you are writing in the English language, it converts that entire code into the binary language, which is zeros and ones. Okay, so the typical .exe files you see in everywhere, right, in the system, those are called the compiled code. It is executable version. So it is, if you run the .exe file, it simply runs on the CPU and provides whatever it is expected to do. Okay, so am I going too speed, or am I okay? Initial thoughts?
Yeah, no, it's completely fine. You can proceed.
Okay, thank you. Okay, so as I explained, so we have machine language, assemblers, and high-level programming languages. So if you just look at the table in the bottom right, so high-level language, as I said, it is in plain English language, so it's very programmer friendly. You can easily understand the language and you can write the code. But whereas in low level, everything you have to write in the binary code. So guys, by the way, you know, right, how to write, how do you convert a decimal to a binary? You are familiar with that? Like, we used to, convert right from decimal to binary. You know, right, guys? If I want to know what is the binary value of 10, can someone tell me? No? Okay. Not sure, pretty much very silence. Guys, please be, interactive. Okay. Don't think me as a, like, teacher. Okay. You can treat me as a friend and we should have a meaningful dialogue. I don't feel like, it should not be a one-way communication. Sorry, someone said something. Okay, so what I'm trying to say is that, like, try to be interactive, be open. Okay, and no question is silly. You can ask any kind of questions on computers. So even in case if I'm not familiar, I can always come back to you on the next day. Okay, so and high level language, like, so it's, as I said, it's very easy to understand, very easy to maintain because everything is in English language. But whereas in the low level language, in the machine code, it's very difficult to write, very difficult to maintain. And the biggest problem is, like, it is machine dependent. So if you code the machine language, it works only on the specific system. It cannot work in another processor or another OS platforms. Okay, and again, high level language, you need compiler, okay, or interpreter. Okay, I will tell you the difference between compiler and interpreter in the next slides, but you need some kind of, converter to convert your assembly code or your English language code into the zeros and ones. Okay, and for machine language, you really don't need any kind of assembler because it's already represented in ones and zeros. Okay, and since the high level language is written in English, it is widely adapted. Okay, everywhere people easily can start learning and coding it. Okay, but low level language, imagine, like, I think you have written the assemblers in your BTech, but are you really using it? No, right?
No, not now actually.
Right, yeah, right. Okay, so here, right, now coming to the software, right? So whatever you're writing the programs, right? So basically, like, if you combine, okay, let's take the classic example of calculator. So what it does, calculator, it adds, it subtracts, okay, it multiplies, it divisions. Okay, of course it does a whole variety of things with scientific calculators, but basic is this four, right? Okay, so consider addition is one program, subtraction is one program, division is one program, and multiplication is one program. Okay, you combine all these four programs and bundle it, and you say it's a calculator software. Okay, so basically it is a set of or collection of programs for a specific purpose. Okay, and this software, like, we have two kinds of softwares. One is system software, one is application software. So as the name depicts, right, system software means the software which is designated to handle the system tasks. The classic example is operating system. So OS, without OS, can you interact with the computer? No, right? So the OS itself is a system software. So it enables or it makes our life easy to communicate with the computers. Okay, and take when you are doing the system boot up, right? It takes the instructions from the BIOS, okay, and reads it, and then it loads whatever is required for you so that you can start working on the Windows. It's again the classic example. And whenever you do the mouse operations, the keyboard or the printer or scanner, so all those, like, the software which was specifically designated for the system purpose, we call it as system software. And application software means it is basically for the end users, for the business users. Okay, calculator, it is designated for the general public, right? So that is called application software. Notepad, okay, the whatever you see, right, the PowerPoint, Excel, Word document. All those are specifically designated for the end user, for the common people. That's called application software. Okay, so program is a set of instructions. So instruction means like as I said, like adding two numbers. So you need to, what exactly you need for adding two numbers. Okay, so you have to key in two values, A or B. Okay, A and B. Then you have to say like what is the sum of these two numbers. So C equal to A plus B. So you are giving few instructions. One is asking the computer to enter a couple of numbers. Then you are calculating, then you are displaying the output value. So there are three instructions here. So those three instructions combinedly, you call it as a program. Okay, so and as I mentioned here, like for the computers to understand, it has to be in the machine code. Okay, and in the regular language like C, C++, VB, C hash, like we are writing the code in high level language, which is in English. Okay, and to convert this, the high level, the English language instructions to the binary code. Okay, so we need to use one of these three: assembler, interpreter, or compiler. Okay, so assembler is basically, if you write the code in assembly language, you need assembler to convert. Okay, and interpreter or compiler, it's both are like it's almost same. Both are used for converting the high level language instructions to machine code. Okay, but the difference is interpreter compiles one line by at a time. So suppose you have like the three instructions. Okay, it first tries to convert the first line to the machine code, and if there is any issues in the first line itself, right, it will stop interpreting. It will just say like okay, hey, there is a problem in the first line, I cannot go to the second or third line. So it interprets one by one. Okay, but in compiler, it converts the entire code into the machine code in a single click. It runs everything. So though if there are any issues in the first line, right, it still continues to convert the second line and third line. But after compiling or after converting all the three statements, if it is fine, it will create the executable file. But if there are any issues in the first line itself, what it does is it will still try to convert all three lines. And before converting the exe, it says, hey, there is a problem in the first statement. Why don't you correct it? So if your program is like, if you are writing a good programming, right, and if you have very less time errors you anticipate, okay, compiler is very fast, right? Because I just said example 3 lines, but we deal with thousands lines of code, right? So it's always compiler is very fast because it tries to convert into machine code very fast because we are dealing with all the lines at a time. So that is the basic difference. Okay, so remember like when basic was introduced, right, basic language, it used to be interpreter only. Okay, and the other language like C, C hash, Java, or everything, now it is compiler, because interpreter it's line by line, it's very difficult. That's why like nowadays almost everybody is using compilers only. So compiler is so can you tell me like compiler is it's a system software or it's a application software?
I think it's a system software.
Yes, very good. It's a system software. Okay, so moving on. So as I said, OS is basically it's an interface between the human and computer, and it's again system software. So coming to the the different type of applications, right? So we have normally like when you start working in the projects also, right? People used to say like the web app, a standalone app. So standalone, as the name says, right, it is installed in your computer and it works in your computer. Okay, so the classic example again I can give is the notepad. It is installed, the software is installed in your system somewhere in the CRD drive. Okay, and it is used to run for your specific needs. Okay, and you cannot run the application without installing in your computer. But unlikely web app, right? Web app means it's a web application and you need to have a kind of a URL or the website. Basically it's a website, it runs on the browsers. So you don't need to install anything except the browser. So you just like enter the URL in the browser and it launches the application. It is called web application. So you can access the application anywhere in the world, provided you have access to that application. Okay, so the typical example is google.com, right, at gmail.com, right? So you can just quickly launch any browser and say gmail.com or google.com. It just flashes the home page. Okay, so this is like a couple of important terms you need to remember: the platform dependent and platform independent. Again, this is very common word you normally use. Okay, so platform dependent. So when I say platform, a platform is nothing but the operating system. Okay, it would be Windows or Linux or Unix, right? So if the program is designated to run specific to one platform, it is called a platform dependent. So if I write some program, right? Okay, if it works only on the Windows, or if it works only on the Linux, if it works only on the Unix, so it is called platform dependent program. But if my program is able to run in different platforms, it's called platform independent. Okay, so our Shiash.net is all platform independent languages. I will go through how we can achieve this platform independence in the .NET. Okay, but for .NET it's a independent. You can write the code and run it in everywhere. Okay, so just a few examples: C, C++ is a platform dependent, and Java.NET, it is a independent. Okay, and again, the different kind of methodologies, programming methodologies. Okay, so some said they know Java, right? So, or some people said they are familiar with C++ also. So I will, if you see there are the methodologies we use in programming is monolithic, okay, and modular, and then object-oriented programming. Okay, so some said they are already familiar with C#, right? So can you tell me which methodology the language falls into? Is it monolithic or modular or object-oriented?
I think it's modular.
Yeah, you say it's a C++ or C#?
C++.
Okay, okay. So I will explain. So see, when the programming started way back in 1960s, right? Okay, we used to have monolithic programming. Monolithic programming means everything you write everything you write in one program. Okay, suppose let's say you have to maintain the students database. Okay, so for student bed database, what exactly you need? You need the student's information, right? Like his roll number, his name, okay, and his family details, okay, and what his score in each of the exams, right? So here you need to write everything in one single program. Okay, starting from accepting the values and saving into the database. Everything you write in one program. So it's monolithic. It's very good. It's very organized. You can easily go through the program and write from the from the input to till saving it to the DB. Okay, so the problem with the monolithic is, okay, it goes on in the same piece of program. The problem is it's very difficult to maintain. Okay, suppose if there is a problem somewhere and you need to identify, so you have to go through these thousands lines of code and try to see where is the issue. And one more biggest problem with the monolithic is, suppose you wanted to use a piece of code repetitively. Okay, suppose, see, the registration is same irrespective of the class, right? But suppose you are taking the data for the first class and you need to take the data for second class. So in the monolithic, you have to write the same set of code again and again, because you need to take the values for all 10th class, right? So it's the code becomes cumbersome. It's not easy to maintain. And if there is any issue, you need to struggle a lot to identify which line the issue is. So basically, you cannot reuse the code. Rather, you have to copy paste the same code. So you are going to increase, the code, the number of lines in the programming language. I don't want to blame this monolithic programming because see, when the programming started way back in 1960s, right? Okay. So the main intention of using the computers is like, to only, to fulfill some specific characters, right? Okay, because nowadays now it is expanded and everywhere, nowadays like we are nowhere without computers. But in 1960s, the adaptability and the usage of the computers are very less, so they started with monolithic. Then people slowly realized, hey, monolithic cannot work because we started using the computers, we spread across to different companies and different shopping. So we need to have a more sophisticated programming language. Then it came modular, or it can be also called procedural programming. So what here it means is, again, if I take the same example, right, the student registration. So instead of writing everything in one big program, what I do is, okay, accepting the values for the student, I will keep it as one block or one module. So when I say accepting means it's like input the data or key in the data. Okay. And then validating those data, whether the entry details are right or not, and the operator has to confirm, whether all good, yes or no, like that. And the third thing is to save the data into the database. So these three things. So typically in the monolithic programming, I have to write this, this inputting and validating and storing the DB. I have to write the same set of code for first class, second class, third class, so on like that. With the model programming, I can write three different modules. Okay, one to accept the values, one is to validate the values, third is to write into the database. So this three I can write into a separate module, and for each class I can just only invoke that module. So that means three modules I am using it, I'm writing, but I'm using it for all 10th classes. So instead of like 3 into 30 in the monolithic, I will have only three modules in the procedural programming. So the classic example is C programming. It is a model oriented, and you might have heard of that functions, right? Modular, maybe you maybe understood, but functions is very the common terminology we use in C language. Functions. Okay, so modular, I would say modular programming is very good. It works. Okay, but again, like why like we again has to move to object oriented programming is because nowadays we are using programming language almost everywhere. So the adaptability is more and more now. It is matured. So we need to have a better way of writing the code. That's where the object oriented programming came into picture. Okay, so it is it started with the C++. Okay, I again like in the C# also we use object oriented programming, and of course in Java also. So it's completely a paradigm shift from modular programming to object oriented programming. Because see, if you are directly jumping into OOPS programming, right, it would be easy for you to understand and write the code. But if you are coming from a C background, right, it would be little challenge. I mean, it's not like that heavily like you need to change your mindset, but because you used to have write in the code in the functions, and again you have to completely move into the object oriented programming. Okay, I will tell you one more example for this. Like see, when the banks, okay, typical, take the example of bank. So bank, what it does, okay, normally you go to bank to open a saving account. I'm just taking the example of saving account. So you go to the bank and you say, hey, I wanted to open my savings account. Okay, so if it is, imagine if it is software, right? So what you need to open a savings account, first you need to register yourself. Okay, you have to provide your name, your address, your some kind of proofs. Okay, that way, like the ATM teller or the operator or right now someone in the bank, right, they can verify your documents and they can key in the data, right? And then it goes for a one line of approvals, like maybe like the bank manager, he has to ensure that what are the documents the user submitted is right or not. They will verify, and then once he approves, it stores in the database. Okay, so here three modules, right? One is opening savings account. Second one is verifying our approvals. Third one is storing the data in the database and confirming or giving the savings account number to the end user. Okay, so it's absolutely fine in the modular programming. Okay, because as for a bank, it is required and I'm fulfilling with my modular programming language and it works fine. So then why do I need to move to object-oriented programming? Okay, so let's take. So if you see here, right, the registration, validation are saving into DB. So let's take example of like, you goes for a vehicle registration or property registration. So everywhere, if you see like general in common, right, you need to have some kind of data to key in so that, it's kind of a profile or KYC, you can say, right? So you need some information to key in so that like, we can, the banks can start processing your account. Okay. And of course, everywhere you see there is a level of approvals takes place to ensure that, the operator did not do any kind of, wrong activities. So someone needs to be, verified and approved. Then finally it is stored. Okay. So here, right, in the object-oriented programming, so these three different methods, right? Providing the details, validating or saving, right? These three in the modern programming, we are calling it as methods or functions. But when it comes to object-oriented programming, we call them as classes. Okay, so these are different. In OOPS, these what are the functions? We move it to the in a new term called classes. Okay, so for now, you just understand that like, we are moving away from the modern programming to OOPS using the classes. Okay, so the biggest advantage is, let's take the government. Okay, the central government or federal government, right? So for government, okay, so they introduce several kind of benefits program. And if you take any benefits program, you always need to have some kind of registration, some kind of approvals, and finally you have to save it in the database. It is common, right? So let's take. So now by creating a separate classes for these different generic purposes, okay, I can keep them at the top level. Okay, hey, okay, you are from a land registration. Hey, buddy, go and use the class which I have already created for you. You just use that and start expanding your scope. So I can give it to the land registration. I can give it to the vehicle registration. Okay, anywhere I can give. Okay, so the for the government, right? So they have a hell lot of various schemes, and everybody wants to follow the same structure. Of course, maybe they need some kind of customization, which we can do with the help of inheritance, which I will talk later. But the core concepts is same. So if you have my 10 different programs in the government, so they can simply access the class, which is already I defined, and they can expand their scope. So you understood, right? Because previously in the model, we are talking about only the bank. It is specific to the bank needs, but now the acceptance and adoption is more, okay, in the computers. So everybody is using. So I moved to the concept of classes, and I'm creating the classes, and I'm asking you to use the classes. Fair enough. Able to understand the difference between modern and OOPS, or any questions? It's very critical, guys, because see, as a when you start into the IT, right? Two things you need to know. One is you have to be expertise in at least one of the programming languages. And I would say now, because now the trend is OOPS, better to learn either C# or .NET or any other object-oriented programming or Python. Okay. And one more thing you need is database. Okay. So be it as SQL Server or it's Oracle, it's up to you. But you need to have one strong programming language knowledge and one strong database concepts. Okay, so it's mandatory, guys. Okay, because without these two, you cannot survive in the IT industry. Okay, so you have to understand, because see, once you understand the concepts, right, it's very easy. It's basically some kind of syntax is there. You need to write if statement some way in a different way in C#, in other way in Java. Okay, but the core concept is same. So please be try to vocal and interactive, and if you have any questions, ask me and stop me and ask the question. So don't wait till the end. Okay, don't keep it with yourself. You are going to be the loser. Okay, so any questions like you understood between the modular programming and OOPS, or any questions? Okay, so I will take it as a yes, and I'll move on. Okay, so now enough basics. Okay, now we'll start the .NET. Okay, so before a .NET, right? We used to have this component object model, because the reason why I'm saying is because I initially worked on Visual Basic. Okay, so before coming to .NET, right? Microsoft was using Visual Basic. Okay, and Visual Basic is the one of the .com model. Okay, it's basically like the biggest problem with the component object model is that it is only used for the standalone and Windows. Basically, I would say it's a machine dependent. Okay, but you know uh, but nowadays, like we are using different operating systems, and we cannot continue using the the COM model. That's where slowly moved from COM model to .NET framework. So the biggest difference is COM is specifically for the Windows OS programming language, Windows OS only. But whereas the .NET, it is everywhere. You can use any kind of platform to run your programs. So we moved from COM to .NET framework. Okay, and one second, guys. Okay, so basically the difference is that .NET framework can be used for any of the operating system. It is the platform independent. And in the COM, we used to have only one programming language, Visual Basic. I'm not sure how many are familiar. It's way back in 2000, 1 or 2. Okay, so now Visual Basic slowly it's faded away, and now everything is in C#. Okay, so just to go a little more details into the .NET, right? So .NET stands for Network Enabled Technology. That means network means it's internet. Okay, and dot refers to object-oriented programming language. So it is object-oriented programming we use to implement the internet-based solutions. So though I say internet-based solutions, but we can still use it for the standalone applications. But almost nowadays, most of the business applications are written on the internet-based only. Okay, and as I said earlier, .NET it's a cross-platform. It's another way to call it as platform independent. Okay, and it's an open source, means anybody can access, anybody can enhance the code. Though Microsoft is the crucial player for writing the majority of the code on .NET, but it's an open source, so anybody can enhance the code. Okay, and so right, Visual Studio is one of the IDE. IDE stands for Integrated Development Environment, where it allows you to write the code and compile and run it. Okay, and the biggest advantage of the .NET is that you can write standalone applications, you can write web applications, you can write any kind of games. Okay, and you can write or you can develop apps on Android as well. Okay, so I said it's a cross-platform. And what is libraries, right? So I told you, right, I have given when I was talking about the government providing some welfare schemes, I told there are some different classes, right? So libraries means in order for you to start writing the code, right? So what this .NET framework does is it has its own set of classes already available. Okay, you just need to start using those classes to enhance your programming language. Okay, so I will when we go in detail, that you will understand what kind of libraries we have, what kind of classes we have. But at this moment, understand that Microsoft already is given some set of foundational classes which can be leveraged by you or by the developers to enhance their application. Okay, so I said framework is it's not a it's basically it's a software and having different classes. But again, one more thing here, right? So the classes, right, it may not be required to write on one specific language like C#. Okay, so it can be anybody can write the classes in any of the programming language which are being supported by .NET, and you add to the framework, and anybody can use that classes. Okay. So here, this is very important, guys. Like, this is the core of the how a .NET framework works. Okay. So I said, like, that the set of classes which are already given by the Microsoft, right? That is called base class libraries. Okay. So what base class libraries is?
A small question. I'm sorry to cut you off.
Sure, yeah.
So you mean that I can use Chash and Fhash for those packages?
Yes, that's right.
Okay.
Okay, it's not only Chash. We have a lot many programs which we can cover later, but
Okay.
the widely used is Chash.
Okay.
So here, right? So base class means, like, it's already available, and it already comes as a it's on the Microsoft .NET framework. So when you download the framework, right? So by default nowadays, in every Windows OS, the .NET framework by default it is loaded. Okay, so it already contains the predefined set of classes which you can use to enhance your development. Okay, so when I say this base class libraries, right? So they are stored here in this code. It is called, see, for the base class libraries, right? You don't need the source code, right? Basically, already the class are written. You just need to start using it. Okay, so the BCL, the base class libraries are, if you want access, basically they are stored here. Microsoft Intermediate Language call it. It's okay. It's not a typical executable file, but it is some sort of, like, close to the machine code, but not 100% we can say machine code. Okay, so but they are stored, they come in this format. Okay, so basically, like, whenever you write any code in .NET framework, right? So you write the code in CS or Fhash. Okay, and once it compiles and it generates an intermediate code. Okay, it is called Microsoft Intermediate Language, or you can say common language runtime. So why this is important, right? So I mentioned, in the previous slides that .NET is a cross machine platform, right? It can work on any kind of OS. Okay, so this code, right? This code is basically, okay, it's a compiled code. Okay, and it is a generic code which can run on any of the operating system. So it is generic compiled code. So what this CLR does is, right? Okay, so basically, because, like, CLR is basically, it's a, you're executing the program, right? So during the execution, it tries to understand what is your system is. Your system is on Windows. Okay, then convert this code to your machine specific code, whether it is Windows or Linux or Unix. So it converts the MSIL code to the machine which you are working on, specific to your OS. Okay, then this is the final, the machine code or the native code. Then it runs. So whenever you are writing any program in the .NET, right? So basically there are two, internally it has two separate process. One is generating the MSIL code, which is a generic, and then leveraging this intermediate compiled code to make it dependent to your specific machine. Okay, so remember, guys, this is the flow. You write the code, you try to compile, it generate the intermediate code which can be used for any of the operating system, and when try to run, it will convert into your machine specific, then it will create the .exe, then it will execute. Any questions here in the flow, how it works?
All good, Venu, from my side.
Fair enough, thank you.
Yeah, no, I'm good.
Okay, so as again, it just depicts, like, whatever I have mentioned in the previous slides. The first compilation, the source code is compiled by respective language compiler and generates intermediate code which is known as MSIL. In the second compilation, it converts to native code, that means specific to your operating system, and this is done by the CLR. Okay, so it says always first compilation is slow and second compilation is fast. That is because in the first compilation, you are trying to convert the high level language to some sort of machine code. which requires some time. But in the second compilation, already the code is already compiled. You just need to convert into your machine specific. That's why it is little fast compared to the first compilation. Okay, so this compilation is normally, the second compilation is done by the just-in-time compiler. We call it as JIT. Okay, so this compiler is responsible for converting the MSIL code to native code. Okay, and when it comes to the framework, right? So we have three different kind of frameworks. One is the .NET framework. Okay, the .NET framework is specific to the Windows OS. Okay, and the second one is .NET, or we call it as .NET Core, which can work across any OS. Okay, and the Xamarin is, it's another flavor which is used for writing the programs for apps, iOS or Android. So these three flavors, but predominantly nowadays we are moving towards cloud. Okay, and it doesn't make sense to depend on only on the Windows OS. So mostly the folks go with the .NET Core framework. Okay, so what is not .NET? .NET is not a OS, it's not a database, it's not a ERP, it's not a testing tool, it's not a programming language. It is a framework. So framework means, I said, it's already, we have some sort of foundation classes developed by the Microsoft and other developers, and they have written in different languages. Okay, and they have converted to the intermediate language, intermediate compiling version. Okay, MSIL, and they are integrated with the .NET framework. Okay, so you just use those .NET framework to enhance your application. So you can write the .NET. I mean, you can develop the .NET applications using VB.NET, C#, VC++, JHash, Fhash. There are so many. Okay, there are many language supports .NET, but the whatever I mentioned here is basically maintained by Microsoft. Okay, and so in the .NET framework, you come across so many, active server pages, active data object, WCF, WPF. These are all like, I mean, I just mentioned for the reference, but don't worry about this. When we go on in the next classes, I will explain, one by one. Okay, so CLR, it's a execution language to convert the intermediate language to the EXE. Okay, and BSL, it's a foundational library. Okay, and we can write the .NET applications using CHash, Fhash, or VB, but predominantly I'm going to cover on CHash. Okay, and just-in-time compiler is the one which converts MSIL to the machine code. Okay, so this is the whatever I explained here, it depicts here. So you can write the code in CHash or Fhash or Visual Basic. Okay, so the compiler, okay, converts into the intermediate language. Okay, and the CLR internally it uses just-in-time compiler to convert into machine code. So generally in any application programming, we used to have only one step paired compilation, but in the .NET, used to have two different compilations. Okay. Okay, and maybe this is too much for you right now. I will just go to the OOPS. Okay, so as I mentioned, object-oriented programming predominantly depends on the concept called classes. So what is a class? So this is what the classes is. Who introduced this OOPS concept to the world? Okay, it says my internet is guys, can you hear me? It says my internet is a little slow. Just wanted to check. Okay.
You're
Okay.
audible. You're audible.
Okay. So do you know now who is the father for object-oriented programming? Anybody knows? Okay, he's
Sun Microsystems.
Okay. I mean, can you name the person who introduced these concepts?
No, I don't remember.
Okay, it's a Grady Booch. He is the one who introduced OOPS concept to the world. Okay, and if you go back and read his books, right, he has given the classic example of cars. Okay, so car is a class. Okay, it's a general, right? So it's kind of it's kind of a like model, or it's a blueprint. Okay, and we have hatchback. Okay, we have coupe, we have sedan, we have SUVs. But the core concept is it's a car, but we have different flavors in the car, right? So here the class car is a class, okay? Whereas this sedan, coupe, SUV, XUV, all these are called objects. That means my object, let's take the concept of SUVs, right? So I have taken the core concept of the class, which is car. So car has contains like typically, right? It has 4 wheels, a steering. Okay, there is a glass in the front and back side and side windows. Okay, and we have like 2 or 4 doors. It's a, the regular car. Okay, and if you take hatchback, okay, we have some like the tail is expanded for more storage, right? And sorry, sedan. Okay, the tail is extended, and SUV you have like a more bigger version, right? And car typically works, I mean the engine is attached to 2 wheels, but whereas in SUVs like we used to have like all-wheel drive like that, right? So basically the concept of the car is same here for all the objects, but they have enhanced their cars for their needs. So as I said earlier, like registration, I have given a class example, right? So registration is a class, but if I want to use that registration class for my bank needs or for my welfare scheme, I may need to change a little bit or customize to my business, right? That is called object. So that means the majority of the code is already there in the class. You just try to adapt it and enhance your code using objects. Okay, so the computer is a class, but you have Dell, HP, okay, and Mac, right? So different flavors, but the core is it's a computer. It's clear, like now I'm just trying to give a real-time example so that it's easy to understand the class and object. And you take any kind of like gated villas, right? So they give one model villa, prototype villa, and they will try to replicate that villa to everywhere in the entire community. And of course there will be small changes here and there according to the owner needs, right? Okay, so I said class is a blueprint. Okay, and object is it's the live example or the usage. So you cannot directly use the class, rather you have to use this class and enhance it for your needs. Okay, and in any class, right? So if you take any class, there are 2 things called methods and data members, or you can say some kind of variables. Variables, right? Variables and methods. Okay, it contains the variables and methods. Just for now, just say that okay, class contains methods and variables. That's what you understand at this moment. Okay, so this guy has taken the example of farming. Okay, if you want to do the farming, right? So first you need to sow the seeds, and you need to do the cultivation. You have to do some watering. You have to add some fertile, and and continue to apply the water on regular basis. Then at some point of time you grow up as with fruits. Okay, so here digging the soil, adding the seeds, okay, and watering. So this is like kind of methods. So in order to get a bigger plant with the fruits, you need to do this. So digging the soil, I would say it's one task. So the task, I would say, method basically. And seeding, it's one more method. Watering, it's one more method. So now you understood, right? So if I want to do the farming, I need 3 or 4 methods. So there are like here I said like 3 methods, right? So basically method is nothing but to perform some specific task. Okay, I will group it into one method. Okay, and here if you see, in order for these methods to work, right, you need some kind of tools. Okay, right? For watering, we need some kind of tools. For digging the soil, you need one kind of tools. So these tools you consider as a variables. Okay, so basically I'm introducing 2 more concepts here. class contains two different things. One is method, another one is variables. So by leveraging methods and variables, you can have one class. Okay, so remember the class contains methods and variables, or you can say normally we say like no data members and methods. So but in the layman terminology, you can say variables. Okay. If the screen is fully visible or like no, is this the top portion is bothering you? I don't know how to hide this. Let me
It's
try to hide.
visible, sir. It's visible properly. Yeah, yeah.
Okay. I mean, do you see this inheritance on the top?
Yeah, we see what is inheritance, we see that. So
Okay,
that's
okay, that's good. Okay. So here, I mean, we have time, right? You guys are okay, right? For another 10 minutes?
yeah, we're good.
Okay, okay.
Good
So
for
you,
I don't know about others.
yeah, guys, let me know, like, if you want me to stop, if it is, enough gyan for today, we can continue tomorrow. But my plan is to take another 10 minutes. We'll try to quickly wrap up the oops here.
Yes, sir, you can proceed, I guess.
Okay, thank you. So here, in these previous slides, I mentioned about class and object. And, I'm going to cover this four at a high level: inheritance, polymorphism, abstraction, and encapsulation. These four I will try to cover and I will wind up for the day. Okay, I know it's too much of theory today, but I promise you that from tomorrow onwards it would be like more of a hands-on. Okay, I will cover some half an hour for the theory, and then we can jump into the practicals for writing the code and compiling and all those. Okay, so for the oops, right? So these four are very important: inheritance, polymorphism, abstraction, and encapsulation. Okay, so we already covered class and objects. So here, inheritance, right? So as as the name depicts, right, it's basically inheritance is basically adapting. Okay, and I told you that like already Microsoft is giving foundational classes, right? So all the classes are there. So what you are going to do is you are going to use those set of classes and try to enhance your business or your application knowledge. So again, you go back to the class example of registration, right? So registration is a class. Okay, and that is a core class, and I'm giving you guys to leverage that class, okay, for your specific needs. That means you are trying to inherit the properties or the methods of the class, existing class. It is called inheritance. So whatever the methods or variables available in the class, you can expand in your class and use it. So the advantage is that already the class are there, so you don't need to write from the scratch. You can try to leverage the existing one and add or customize for your business needs. Okay, so here the core class is called parent class, and since you are the one who is trying to adapt that class, you are called as a child class. Okay, so here you see an object or forget about child. So a child class inherits all the members of the parent class. When I say member, it could be methods or it could be variables. It's called parent and child. I mean, you will get to know more how you, when you start writing the code, how you are trying to implement. But right now, just try to understand the concept as just a theory. Okay, so here you have to forgive me. This is the code written in Java, but just I will just try to explain here. So here, there are two classes here. One is class called another class. Okay, and here I'm having a method called add. So I'm trying to add two numbers. Okay, and trying to output the data. This is one class. Okay, and here one more class. I'm trying to use this another class. Here I'm using extends word, but it is in Java. I will explain in C# how it works. But you're trying to use the under class, okay, and extending it. So here, what you're trying to do here in the main class, you have the function of adding two numbers. Okay, in the child class, you are using the function, that add function, and you are providing the input values here. So you are just trying to use the parent class, okay, and providing the values. So here another class is the parent class, and since you are trying to use it in your main class, it is a child class. So basically you are just trying to use the parent class and executing it. Okay, so basically, you're just you're invoking the add method here, passing two values 3 and 5, and the output is 8. Okay, here like in inheritance, we have like three different ways. One is single inheritance, multi-level, and hierarchical. Single means the previous slide, right? It's directly you're trying to adapt the child class. Okay, you're trying to adapt the parent class. So it is just a one-on-one single inheritance. Okay, so the parent class properties is derived in the child class. Okay, and multi-level, it's like, as I said, it's a multi-level, right? So the class A having some set of functions, and you're trying to use the class B, and again from class B you're trying to use the class C. So the class A properties comes to class B, and class C properties contains class B plus class A, because we are trying to inherit the A and B here. It's called multi-level. And hierarchical, right? Hierarchical means, okay, so more than one child class trying to access the parent class. Okay, so the class B is trying to use class A properties, and class A also trying to use class A properties. So single, multi-level, and multiple. Okay, and so clear, right? I mean, inheritance at a high level you understood, right? We're just trying to adapt or trying to expand the existing class, and modifying or customizing for your needs. So I mean, when we just typical example I have given registration, that is a very good example for inheritance. Okay, and another one is polymorphism. So polymorphism is right, like now, so it's the class example is given moon. So moon, you take 15 days of the cycle, right? So you see different views for a moon. It's a moon, but it's a different form or different shapes. Okay, so basically the object is, or the class is same, but the way you are trying to use it is different. Okay, so in the polymorphism there are a couple of concepts called method overloading and method overriding. So method, I told you, right? Class contains method and variables. So try to remember that, the core concept. Okay, so overloading means, okay, the same method you can use for different purposes. Okay, I will tell you how it works. Let's take the example. Okay, it's again written in the Apollo. It's written in the Java. System.out.println is, it's a object we use in Java to print something on the console. Okay, so here the println is a method, and you're trying to print the please don't here. Okay, again the same println method. Okay, but here instead of using the the constant word, you're also having to add some additional values here. Okay, let me show you here. So the base class contains please don't. This is the one it has. Okay, and here it says oops, couldn't hold it for long, and laugh. Okay, here basically if you try to invoke this println method, okay, it will try to invoke this, because this is the base class, this is a child class. Okay, and child class has a different wording here, and since you are trying to use this child class method, right, it will print oops, couldn't hold it for long. Hey, did I go wrong? 1 second. One second, guys.
Yeah, looks like, sir,
me.
because there's no second class there, right?
I'm just okay. Yeah, one second. This this top is bothering me. I don't know how to hide this, the top screen. Okay, let me do one thing. Let me go like this. Here we are. Okay. Okay, so here the main class contains don't overload me, okay, and it is trying to print please don't, okay. And here one more class called don't overload me, and it is trying to print oops couldn't hold it for long, and public static void main string don't overload me. Okay, so here basically it has only one class here, right? It's only one method, okay, and we are invoking that method directly, okay. But come to the second one, I will show you here. So here, right, here we have one method don't overload me, it says please don't, okay, and one more don't overload me, okay, and it's oops couldn't find and laugh, okay, and you are invoking this overload me with a parameter, okay. So you just see here I said method overloading, right? So basically if you see the method name is same, one is don't overload me, it's same method, but the parameter is taking is different. In the first method it is taking only a static constant please don't, but in the second method it is taking oops couldn't hold it for long, and it is taking one more parameter called laugh here, right? And here you are passing this value, okay, so don't overload me, and you're passing this ha ha ha. So you're passing a value, okay, to the method. So since you are passing this value to the method, it invokes the second one. You get it, right? Because if you see the first method, it doesn't have any parameters here. We are simply calling the method don't overload me. There are no parameters here. But in the same method don't overload me, here you are passing one more parameter called laugh, the string function, string variable, right? So since you are passing this ha 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 as a variable to this method, so what it does is it tries to see, okay, I see two methods here, and which one I have to execute. Okay, so this guy is calling the method with a parameter, okay, and this first method doesn't have any parameters, then let's skip it. It goes to here, okay, there is a parameter here, and it takes that value laugh, and it prints oops couldn't hold it for long, and then ha ha ha. So basically if you see here, the method is same method we are using it, but we are having two different. So one is direct statement print, one is by passing some additional values. Okay, so basically that's what like polymorphism, right? So basically different shapes. It's a moon as an object, it's one moon, okay, but every day it appears differently, right? So here the same method don't overload me is the method, same method, but the way you are passing the parameters, it executes differently. One is without any parameters, one is with parameters. Okay. Okay, now another one is overriding. So overriding means, okay, so in the inheritance we mentioned that like we have the parent class and we have child class, and whatever the methods and variables which contains in the parent class will be coming to the child class. Okay, suppose you have one method in the parent class and you don't want to use that method, or you want to use that method for different purposes. You have some different purpose for the same method. So by default, it contains or it inherits the properties of the base class to the child class, but you can use the same method name and write for your own separate logic. So that means the method which is written in the base class or a parent class is being overridden by the child class. That is called overriding. So you are overriding the method defined in the base class by introducing a new code in your child class. Okay. Okay, here you see. So in the parent class, you have called old method. Okay, and it says parents rock. Okay, that's the print you're trying to do. And in the child class, you're using the same method, but you said children rock. By default, like if you don't use this one, right? If you invoke the old method, ideally it should print parents rock, but you have overridden the parent class functionality, and you have written an additional piece of code to print something different, right? So child class is inherited from the parent class, which contains a old method. Okay. Right. So parent clock rock, and you are extending the parent class and you print one children rock. And here you are trying to invoke the child class, right? And when you invoke the old method, it prints children rock. So you are overriding the base class method in the child class. Okay. Okay, probably we can just quickly jump into. So just to summarize, overloading is two or more methods in a class to have same name but different parameters. Okay, so overloading prevents us from writing the multiple methods which perform the same task. So imagine right now you want to print a static statement, you have to print with some variables. So instead of writing two different methods, you can write the same method name, but you can just by passing different parameters in the method. Okay, the compiler invokes the right method during the runtime. So overriding is okay when two or more methods in a class have the same name and same parameters, but the method which overrides the previous one is written in a child class. Okay, so now you play with the inheritance and polymorphism, right? So let's go to. Okay, I will just skip for now because we are running out of time, so we can cover tomorrow if needed. So 5 more minutes, guys. So abstraction. So abstraction is okay a process of hiding the implementation details from the user and providing only the functionality. Okay, so guys, if you want to drive a car, what do you need? You need how to control your vehicle, how to change the gear, how to use clutch and pedal, and how to do the steering. Do you really need how the engine works? Okay, do you really need that? We only need how to drive. Okay, so the internal part of the car is irrelevant for us, right? So same way with the oops, right? So we hide the implementation details. We only give the what is required for the users. Okay, so take the same example of the classic example of the registration, validation, and saving it to DB, right? Suppose let's say like okay, I have developed these 3 methods, okay, and I'm giving it to you guys. Hey guys, I have 3 methods, and you use it these 3 methods. Okay, so not all of you may not know that like you have to first invoke the registration, then invoke the validation, and then invoke saving. What happens if you invoke these methods in a different order? You invoke first save DB, then registration, then validation. Is that solves your purpose? No, right? So then what I do normally, ideally, what I have to do? I have to write these 3 methods like registration, validation, and saving DB into one more method. I will give only that method to you. Hey guys, don't use the 3 methods, just use registration method. So what happens? You just invoke the registration method. Internally, it invokes the registration or input in the data and validation, and then writing into DB. So you really do not require how that works internally. So exactly that's what here abstraction is. So abstraction is whatever is needed, okay, we provide. Rest of the things we just hide it in the parent classes. Clear? Abstraction. Any questions? The same thing computer also, right? You really don't need how computer works. How the instructions are fed into the main memory, how the CPU calculates the values, and how it gives. You just need some keyboard, okay, and just you can start run plug in and just start using the computer. You really don't require how it works internally, right? That's called abstraction. So whatever is required, that only we provide to end user. Remaining we hide it. Okay, and okay, we'll just go to the last topic. It is encapsulation. Okay, so here also, right? So basically, I mentioned that class contains methods and variables, right? And anybody can use that class for their business purposes. Okay, so here in the encapsulation, right? we are combining these methods and variables into one entity that is called encapsulation. Okay, so you take the classic example here, right? So if you take a container, right, it contains some marbles. Okay, it has some water, and if you want to remove these marbles, you need some kind of spoons or tongs, right? So let's take this take it as a class. Okay, and this marbles represents methods. Okay, and whatever the spoons or the sticks, you need to to pull these marbles, right? It's called variables. Okay, so I'm just trying to make it very simple. So basically the encapsulation is the combining two things, methods and members, into one entity. Okay, so here, right, here I said variables and methods, right? So variables are declared private. So there are two things which you come to know more frequently. One is private and public. When I say private, it is that can be only worked within that class. It cannot be used by outside the class. Public means you can use it outside the class. So when you try to inherit the parent class to a child class, right? Let's say, like, now if there is a variable defined in the private, right, you cannot use that variable in the child class because it is declared as a private. And suppose if it is a method declared as a public means you can access the method beyond your class also. So normally in the OOPS concept, okay, normally the methods are declared as a private, so methods are declared as a public and variables are declared as a private. The reason because is, when you declare the methods public, right, you can extend the scope and you can invoke the method in the child class. So really do not need to invoke any of the variables in the parent class. So this is the way we achieve the OOPS concept. So one is polymorphism, one is encapsulation, one is abstraction, right? So all these combining called OOPS concept. So I tried to cover only in a very high level just to introduce you the OOPS concept. But when I go in detail in the programming language, right, we'll have a separate dedicated classes for each and every concept. Okay, I know I think probably I may little rush, but guys, let me know, just go through. I will share this deck with you all. Go through it. Okay, try to understand, and probably we can tomorrow when I start, right, you can ask any questions. First 5-10 minutes I can dedicate for any FAQs from the previous session, and I will try to clarify any of these questions. So for now, what to do is install the community edition of the Visual Studio. Okay, hope you guys are familiar. Let me. Okay, Visual Studio, just click on Visual Studio installer. Okay, and then the very first thing right here, see Visual Studio Community Edition. Okay, install this. Okay, and keep it ready. And because from tomorrow it would be like kind of more hands-on, because I'm going to introduce different concepts in the programming language. So you will basically will spend some time on the theory, then we'll jump into the Visual Studio to write some code and to execute. Okay, so it would be more of a hands-on. So my request is you download this Visual Studio Community Edition 2022, and tomorrow we can start with the our the simple Hello World program. Okay, so I would like to put a stop here. So any question we wrap for the day? And also, guys, let me know if I'm going too fast. I can try to reduce my speed. Instead of going 1.52x, I can try to come down to 1x.
No, it's good.
Good. Okay.
Yeah, I think the speed is good,
Okay. Okay. So yeah, please.
Actually, I have a quick question. So
Sure.
are we going to concentrate about web apps as well on the framework?
Yes. We'll cover web apps. That.
Okay. yeah, I mean the DAO layer, the controller layers and all that stuff as
Yeah,
well.
yeah,
Right?
right. MVC, right?
Yeah, the MVC
Yeah.
framework.
Yeah. We'll cover, but
No.
may not be, from tomorrow, because my plan is first week I wanted to introduce all these concepts one by one. Then
Yeah,
we can focus the bigger things.
Sure. Perfect.
Yeah.
Thank you so much.
Guys, any other questions? Well, so I will take it as a no. Thank you very much. But you seems to be very, in the listener mode. Okay, I need you to be more interactive. That way, we can, I told you that it's not like, I'm one-way communication. I wanted to be a two-way. So please try to be, more of interactive, so we can utilize this hour effectively and, try to clarify any of your questions.
Yeah, sure, Anna, definitely.
Okay. Yeah. All right, then. Okay. So thank you very much for patiently listening to this the first 1.5 session. We'll meet tomorrow same time, and we'll rightly jump into the programming tomorrow.
Sure, Wendy.
Okay.
Thank you.
All right. Yeah. Thank you so much, and have a good night, guys.
Good night.
Thanks.